I'm going to be doing an exam today. This is the 2021 NCEA 3 exam, statistics, apply probability concepts in solving problems. Back in the good old days in 2021 when you probably had to sit your exam wearing a mask. So this is worth 4 credits. If you want me to do an exam, let me know. It doesn't have to be a New Zealand exam. I'll do any exam within reason. Okay, so I'm going to be using the paper that's online, the most common calculator that students use, the FX 986, and the formulae sheet that they give you. So with that, let's do it to it. So the first question, a music and dance festival sells 2 types of tickets. I'm just going to move it up. Early bird and general admission tickets. So let's do these, and these are GA tickets. For each ticket type, the festival attendees under the age of 16 buy a child ticket. Okay, so there's child tickets. Otherwise, an adult ticket is required. Early bird tickets need to be purchased before a particular date and are cheaper to purchase than the general admission tickets. Okay, a lot of information they're giving us. Not a lot of it useful so far. For both early bird and general admission ticket types, child tickets are cheaper than adult tickets. Okay, kids have one thing, you get to go to music festivals that are cheaper by the looks of it. Well, the kids in 2021 were anyway. For the 2021 festival, 1/5 of tickets sold were early bird types. For those early bird tickets, 3/4 were adult tickets. So 3/4 were adult. And I guess that means that 1/4 were children. I guess there wasn't a sort of a senior citizens price or anything like that. For general admission types, 2/3 were sold were adult tickets. So 2/3 were adults, which means that children were 1/3, apparently. The festival organisers predicted that 10% of their ticket sales would be children early bird tickets. Were they correct in their prediction? Well, let's find out. And this is sort of crying out for a diagram, a tree diagram. So let's say this is early bird. So they tell us how many of the early birds. 1/5 were early birds, which means general admission was 80%. And then we can split those up, adults and children. So this is adults, this is children, this is adults, this is children. So early birds, 3/4 were adults. So 3/4 or 0.75 were adults. And that means that 1/4 or 0.25 were children. And for general admission, 2/3 were adults and 1/3 were children. Okay, so we've got all of our 4 possible outcomes, and we want to test children who bought the early bird tickets. So we're just using this branch. So the probability that a person chosen at random was a child who was an early bird is going to be probability that they were an early bird times the probability that they were a child. No, not that one. It's going to be that one, isn't it? Times 0.25. It's the probability that they were a child given the fact that they were an early bird. So let's our calculator, and 0.2 times 0.25. And we get 0.2 times 0.25. And we get 0.05, which is 5%. So no, they only got half as many as they wanted. Half of 10%. Next, we are asked to calculate the overall proportion of tickets that were sold to adults. So in other words, we want to find the proportion of adults who went the early bird route and the general admission route. So there are two categories that make our category that we're looking for. So the first one is adults that went to the early bird, so that's going to be 0.2 times 0.75, 0.75. And then we want to add those adults that were general admission. So general admission were 0.8 times 2 over 3 times 2 over 3. And I'm just going to keep it 2 over 3 and grab our calculator. So brackets 0.2 times 0.75 plus 0.8 times 2 over 3 in brackets, and we get 68.333. So 0.68333 on and on, which is 68.3%. 3 significant figures I'm going to put, or something like that. We then asked, is it more likely for an adult ticket to be sold to an early bird ticket holder or a general admission ticket holder? Well, we kind of already answered it in this question up here. Remember, these were the early bird adults and these were the general admission adults. So the proportion of adults, given the fact that they were early bird, versus the proportion of adults given that they were general admission has already been worked out for us. So this is going to be 0.2 times 0.75. Let's move that up a bit. And this one here is going to be 0.8 because general admissions were 80% of the tickets times 2/3. So this is going to be two different numbers. So 0.2 times 0.75, 0.15. So 15% of all of the ticket holders were adults that were early bird buyers, and 0.8 times 2 over 3. I always put the brackets in these Casio calculators. 53.333. Okay, so we're talking about 15% versus 53.333%. So a lot more. How many more? Let's divide that by 0.15, and it's over 3.5 times more likely that an adult chosen at random is going to have gone through on general admission rather than early bird. And here we see, in order to encourage people to buy tickets early, organisers decide for the 2022 event to increase the price of the general admission tickets. That's not going to end well, I don't think, compared to the early bird tickets. Note that in the 2022, the relative proportion of adult and children tickets are expected to remain the same. Okay, if increasing the price of the general admission tickets in 2022 reduces the proportion of all tickets purchased as general admission to 1/2 of the original proportion comments on the effect this change would have adults who go for general admission versus adults in early bird. Well, it's going to be almost exactly the same as before. So we're going to start here, and these are going to be our early birds. And this was, I think, from memory, 0.2 and 0.8. 0.2, and this was the general admission, 0.8, but now it's just going to be 0.4, and we're going to say that half of those people, so our train of thought stops there. So for adults and children, up here, adults were 3/4 and 1/4. 0.75, 0.25, this is adults, this is children, and this is adults, and this is children, and we're told that the ratios were the same, so it's still going to be 2/3, 1/3, 2/3, 1/3. So now the proportion of adults who went GA is going to be 0.4 times 2/3, and the proportion of adults who are early bird is going to be the same, 0.2 times 0.75. Okay, so effectively these are being taken out of the population. So then we grab our calculator and find the new numbers. So 0.4 times 2/3 is 0.2, we'll say 26.667%, and 0.2 times 0.75, I think we may have already worked it out, but I'll work it out again. 0.15, which is 15%. So long and short of it is that more adults chose general admission, but not as many as before, or any way that you want to word that, that's fine. Maybe not a good choice to up the price. Right, this next one's a bit of a stinker. So we're told that they aim in the 2022 festival to increase the proportion of all child tickets that were early bird to 30% of all the tickets. 30% of children, I think they mean. So in other words, we want 30% of children to be early bird. Okay, calculate the overall proportion of tickets that would need to be sold as early bird tickets in order to increase the proportion of all child tickets that were early bird type to 30%. Let's have a look at our map. So this is early bird and this is general admittance. So we've got 7.75 here, 0.25 here. So this is adults, children. This is adults and children, and this was 0.2, 0.8. This was 2/3, and this was 1/3. So in other words, they want to change that number there So this number here is 0.3 of all children. Okay, so this is the variable that we're going to be after, and I'm going to call that proportion, I'm going to call it P's already taken, let's say B. Okay, so that means the following. That proportion B of the early bird times the 0.25, I guess that's going to be over all of the children, plus, so this one here is now going to be 1 minus B because they have to add up to 1. So 1 minus B, brackets, times 1/3, close brackets. And that all has to add to 0.3 for 30%. Okay, so I'll go through what I've done. So this is the number of children who are early birds divided by all the children. So these are the early birds, these are the general admission. So 1 minus B is what's left after we've taken that B out, times the 1/3 of children that go along to there, and we want that to equal 0.3. So now we have one equation and one unknown, but the unknown is in 1, 2, 3 different places. So it's time for our calculator. We could do it by hand, but let's not do it by hand. No, don't want that. We want the solver. Delete everything. So we want brackets x times 0.25, close brackets, and we're going to need 2 sets of brackets, aren't we? There, plus brackets 1 minus x, brackets, and we're going to need another set of brackets, times brackets 1 over 3. Now have we got enough brackets? 1, 2, 3, 1, 2, 3, 2, 3, and it's going to be equals 0.3. Cross your fingers. 0.36363636. How about that? So 0.36363636. 30%. Hey, so that would be excellence question. So question 2 says that there are 3 different festivals being held this summer break. One at Idle, one at Escapade, and one at Serendipity. Different performing groups or individual acts can be seen at the different festivals. There are 37 acts performing across the 3 festivals. Idle has 17, Escapade has 14, Serendipity has 29 acts. 5 of these acts can be seen at Idle and also at Escapade. 13 can be seen at Idle and Serendipity. 3 acts can be seen at all 3 of those festivals. So this is crying out for a Venn diagram, isn't it? Calculate the proportion of acts at Idle that are unique to that festival. Okay, let's do our Venn diagram. You just have to pretend that I can draw. So I'm going to say that is Idle. That's Idle there. That's Serendipity there. What was the other one? Escapade is there. And they tell us that 3 of these acts can be seen at all 3 festivals. There is nothing outside, so there is an empty set that's not included there. So all of these are going to add up to 37. So Idle has 17 acts. 5 acts seen at Idle can also be seen at escapade. Well, that must mean that there are 2 there that are just escapade and the other one idle, because we have 5 there. The other 3 also play serendipity. 13x seen at idle can also be seen at serendipity. So 13, that must mean this is 10. So now we can work out idle. So idle is going to be 17 minus 2 minus 3 minus 10. So what's that going to be? This is going to be 2. So 2 out of 17 are just at idle. Now, how are we going to work out the other 2? We don't necessarily need to in this case, but the way we're going to work it out, I'm going to say that that is A, that is B, and that is C. So what is left over after we've put those numbers in there? Well, there must be left over. There's 37 that are accounted for, and there's 17 that we know that they're going there. So A plus B plus C equals 20. We know that this is serendipity here. It has 29. So in B plus C must be 29 minus 13, which is 16. And we know that in A and B, escapade has 14x. 5 of them are accounted for. So A plus B must equal 9. And now we have enough to solve our equations here. And it works out to, what's this going to work out to? So A must be 4, because if B plus C is 16 and A plus B plus C is 20, that must be 4. So that must, A must be 4, so we can make it about that. B must be 5, because 4 plus 5 is 9. And that tells us that serendipity is 29 minus 18. 29 minus 18, anyone? Let's work it out. 29 minus the 10 here, minus the 3 here, minus that 5 there is 11. So there must be 11 that were only at serendipity. So we did kind of like a system of linear equations to solve that. Okay, calculate proportion of acts at idle that are unique to that festival. So it's 2 out of 17. Good question though. So now we're asked, which 2 festivals have the greatest probability of seeing the same acts, of people seeing the same acts? So we could go with either this one, idle and serendipity. We could go with idle and what was the other one? Escapades or whatever it was. Or we could go with serendipity and escapades, and I think that's it, isn't it? That's all. That's the only 3 there are. Okay, how many acts are there in both of those, and how many of them are playing at both? Well, idle and serendipity. So here's idle and serendipity. So there's 17 plus 5 plus 11. Ugh, not my good day for sports today. So 17 plus 11 plus 5. So 33 participants went to either all of those concerts. So that's out of 33 there. How many of them are double acts? Well, 13. Okay, idle and escapades. So there's 17 that went to idle, plus 21, 26. And 5 of those were double booked. And then serendipity and escapism, there were, how many did we say were at each of those? So escape, serendipity had 29, plus 6 is 35. X in both of those. How many of those were repeats? 8 of those were repeats. So which of these is the higher proportion? 13 divided by 33 is 0.39. 5 over 26, going to be a lot less, so 0.07. And the last one, 8 divided by 35 is 0.22. So the most common was idle and serendipity. You're most likely to see a repeat band. Just under 40% of their bands were repeat acts. Next, we're told that a particular festival attendee can afford to attend only one festival. I've been there, buddy. They wish to attend the festival that will give them the highest probability of seeing a unique act, one not able to be seen at any different venue. Which festival should they choose to attend? Well, the probability of a unique act at serendipity is going to be however many people were at serendipity, 29 people. And how many of those 29 acts, how many of those were original? 11. 11 out of 29. Unique, it's, what were the other ones? The idol. How many were at the idol? There were 17 at the idol. How many unique acts were there? 2. Not that great. And probability, unique, escapade, acts in total at escapade, and 4 of them were originals. So if we convert those to decimals, we'll get the answer. So 11 divided by 29 is 37.9%. I'm just rounding them. 2 divided by 17. 2 divided by 17 is 11.8. 11.8%. And 4 divided by 14 is 28.6. So our winner is serendipity. Next, we're told that the boffins have been on the case, and for the number of people who attended one festival, a model was developed that predicts the festival a person will choose to attend based on various characteristics of that person, variables such as age, income, and home location. Okay, fair enough. To test the model, a group of 214, so n equals 214, were surveyed, and the actual festival chosen by each person was compared to the predicted festival from the model. So these are the predicted festivals. This is where they actually went. Calculate the percentage of the predictions that were correct. The predicted festival was the same as the actual festival. Okay, well, 80 people were predicted to go to Idle, and they went to Idle. 25 people were predicted to go to Escapade, they went to Escapade. 5 people were predicted to go to Serendipity, and they went to Serendipity. So that's going to be some number over 214. So 80 plus 30 is 110. So 110 divided by 21. That was someone sneezing in the other room. So 51.4%. 4%, 3 significant figures. There you go. So now we're asked to comment on the appropriateness of the model for predicting attendance at the different events. Support your answer with at least one additional calculation. Well, this 51% number here is being rescued by this really. 80 people predicted, 80 people went. Far more than went to other festivals. But this figure sort of falls apart. We predicted these people predicted they would go to Escapade, and only 25 of the 70 or so people actually went, so that throws us out. They were wrong there, so they were right for Idol, they were wrong for Escapade, and then Serendipity, they were way wrong. They predicted Serendipity 40 times, and only 4 of them came out. So only 5 out of 40 were correct. So they got a big cross here. So it was well in predicting that we're going to go to Idol. It was really poor for predicting that it was going to go to Serendipity or some other answer. And now we have a tale of woe about Patrick, who owns a food caravan, sells food and drinks at the festivals. He purchases a bulk pack of 300 canned drinks, which were advertised as being supplied an equal proportion of cola. Okay, so they're getting around copyright. Cola, lemonade, and orange flavors. We won't say what type of cola, what type of lemonade, or what type of orange flavors they are. So he's presuming here that it's a third for each. The cola is usually the preferred flavor for festival attendees. So consequently, Patrick is disappointed when he counts that there are only 85 cola drinks out of his pack of 300 cans. So 85 over 300 does not equal 1/3. So he's a bit got his nose out a bit. Patrick thinks that his bulk pack is likely to be representative sample. It's a big call of drinks produced by the manufacturer. He wonders if the proportion of cola drinks supplied is less than the advertised proportion. Fair enough. Discuss how carrying out a simulation would help Patrick consider whether his bulk pack could indicate the proportion of cola drinks supplied by the manufacturer is less than 1/3. Okay, so as part of your answer, describe what evidence Patrick would look for in a simulation that would justify making a complaint to the manufacturer. So he's going to want to avoid doing a simulation like a bootstrapping simulation on, is it 2Ps? On the sample he's already got, because he already knows that it's biased and that 85 out of 300 are a Coke bottle. So just repeating, counting them over and over again is not probably going to help much. He's going to want to do really a survey of types. So he's going to want to know that different vendors, different circumstances, also have the proportion of cola is less than 1/3. So I mean, it could just be that he wants to be able to in other words, he wants to be able to put his 85 out of 300 cans is outside the acceptable thresholds. Because next time he might get 111 out of 300 cans which are cola. He might get 102 cans out of 300 that were cola. He might get 98 out of 300. He may get 82 out of 300 next time. He wants to know that this is a representative sample and that regardless of where he buys it from, he gets it from the proportion of cola kids is going to be less than 1/3. So he needs more in his sample. And that doesn't necessarily mean driving around the country and sort of pulling over cola trucks and counting the cans. You probably, the number of cola cans in your batch would be the least of your problems if you did that. But I mean, he could call around other vendors and say, like, how many did you get, and do an informal survey that way. A simulation, though, maybe not so great, because he knows that the information he's got, so he would be suffering from gigo at that point. If he put the sample that he already has in, he'll be garbage in, garbage out. So bootstrapping probably would not help him, but expanding his sample size would help him. Rightio, on to question 3, and this has got to be one of the most convoluted questions I've ever seen. So festival tickets are sold either online or through a ticket office at the venue. So that's a bit of a problem straight away, online or through a ticket office. The organisers have gathered data from the first 1,000 festival attendees to buy their tickets online. So N is going to be 1,000. The data summarises the age of the festival attendees, 25 years or younger or over 25. Their main motivation for attending the festival: dancing, socialising, or other, whatever that is. 750 of the festival attendees are less than 25 years old. The main motivation of 510 of them is to dance. The remainder of those younger attendees is evenly split, mainly interested in other unspecified reasons. For those in the older cohort, 160 are mainly interested in socializing, and of the remainder of the older attendees, 60% are interested in dancing, which means that the other 40% are interested in other reasons. So let's break this down. So the first most logical way to break it down is, are they greater than 25? And we're told that 250 of them, so 0.25 of them, are over 25, so that's 250. And of those, 160 are interested in socializing, so this is socializing, so 160 over out of 250, socializing, dancing is 60% of what's left, so there's 90 left, so 0.6 times 90, so 0.6 times 90 is 54. Out of those, 250 are interested in dancing, and other is whoever's left. So 250 minus 160 minus 54 is 36. So 36 of these oldies up to no good. We're going to say this is other. Now for the over 25s, this is under 25s, this is 50 of them now. So 510 out of 750 are interested in dancing. Good for them. Let's give ourselves lots of room. And the others are evenly split. Okay. So 750 minus 510 is 240. So 120, 120. And 120 over 750. This is socializing. This is other. Let's move that up a bit. Okay. Calculate the probability that the festival attendee, so a festival attendee is chosen at random. Calculate the probability that the festival attendee is less than 25 years old and is mainly interested in socializing. So it's going to be this branch here. So it's going to be 0.75 times 120 over 750. It's going to be a number. 0.75 times 120 over 0.12, so 12%. Next, we're told that festival organisers claim that it is at least twice as likely for the younger participants, less than 25 years old, to be mainly interested in dancing compared to the older participants over 25. So at least twice. Does this data support the claim? So there's a big caveat. Remember, this is only the first 1,000 people who bought their tickets online. So people who buy tickets to festivals online early are going to be different from people who decide a day before that they're going to go and rock up on the day. So just bear that in mind. So using their data here, what's the probability that a person is into dancing given the fact that they're over? So how many people are into dancing that are over 25? 54 out of 200. And probability the person is interested in dancing given the fact that they're under 25. So dancing was this one here, 510. So let's convert both of these to decimals so we're dealing with apples and oranges. So 54 divided by 250 is 21.6%. So 21.6% of, I won't say adults, but over 25s are there for dancing. And of the under 25s, 510 divided by 750, exactly 68% of the under 25s for dancing. So yes, in fact, it's almost 3 times more likely that a younger person is there to dance. Okay, so now we're told that we're asked, are the event's festival attendee is less than 25 years old and festival attendee is mainly interested in dancing independent? Are they independent? So we need to do our independence tests, and from what I can see, there's 2 possible ways we could do it. We could say the probability that someone is under 25 given that they're dancing. Okay, that's one thing, and we know that that number would be 510. Now the number of people dancing is 510 for the young'uns and 54 for the old'uns. So what's that? 5. Okay, and compare that to the probability that a person is just chosen at random is under 25, and we know that that's 0.75. So 510 divided by 56 is 0.9. So 90% of under 25s are dancing. So 90.4%, they're not the same. Or we could, what else could we do? We could compare the probability that someone is dancing given the fact that they're under 25, and it's going to be 510 out of the 564 again, versus the probability that someone is dancing regardless of their age, and that's going to be over 1,000. So it's going to be 510 plus the 54 again, so that's going to be 564. So we know this is 90.4%, and we know that this is 0.4%. There's a significant drop off from when we add the people who are over 25. So no, they are not independent events. So I've kind of already answered this question. It wants us to interpret what I said in part 1 in terms of the relationship between festival attendee is 25 years old and festival attendee is mainly interested in dancing. Well, the propensity, if that's spelled right, to dance seems to diminish over time. Seems to diminish, shouldn't be an H there, with age. So if we have here someone really wants to dance here, the person there, they're all jumping up and down, propensity to dance over age. I guess it kind of goes down there like that. There's one way of showing it. This is the under 25s, and this is the over 25. There's less of them. These people are kind of like the Bee Gees. They feel like dancing, whereas the oldies, it's just a small lot. That embarrassing person who's always on the dance floor, aren't they? I mean, I'm an old codger now, but I hope I'm not that old codger who's, you always used to say, oh, give it up, granddad, come on. But there you go. You'll get old someday, kids. And here we go with the last question. Give 2 reasons why we should take care using this data to predict that a new ticket purchaser buying a ticket will be less than 25 years of age and mainly interested in dancing. Well, it was done online, and younger people tend to do that online. Okay, that's one thing. Secondly, it may have been advertised as a dance party. You have to call it a dance party. A dance party is legal. A rave will get the police involved. Okay, so people may have seen it online, advertised. Oh, okay, let's go have a dance, and while we're there, we can have some cola and orange flavored beverages. So be very, very careful that the method itself is biased. I mean, maybe they want it to be biased. Maybe they want lots and lots of young people showing up and having a blast and enjoying their time. That's why you're young, Youth is wasted on the young.
I have one simple request, and that is to have sharks with frickin' laser beams attached to their heads.